Welcome to KMIT Vista. In this today's session of Artificial Intelligence, Technologies and Applications, we will be studying about our fourth chapter. So, in this fourth chapter, we will be covering different types of AI based projects or AI with ML based projects. And here in this fourth unit, we have the role of AI in agriculture. So, we have AI for the smart agriculture and the prerequisites and advantages of AI and ML models required to design the AI for agriculture and different applications that we are going to see in this chapter and the future trends in agriculture with respect to AI. So, using nanotechnology, using fog computing, what is the necessity of blockchain, what is the necessity of big data. So, all this we are studying in this chapter and we will see the end-to-end project design of AI ML based agriculture systems. In this session we will be studying about the prerequisites to build the AI ML based model or end-to-end AI system. So, we will be seeing the advantages of AI in agriculture. So, coming to the prerequisites, we know the building of ML model, how to build a model. So, we will be seeing building a model for agriculture. So, building an ML or AI based agriculture model involves several critical prerequisites that ensure the most effective, accurate and practical applications that are used in the designing the model for agriculture. So, if we see to design a model for agriculture, we need all these blocks. Okay, so we need all these resources such that we can design an end-to-end project. So, first one we need the domain knowledge and we need a data collector and we need a data processing system, we need infrastructure, we need model training and model validation, next integration and development, monitoring and maintenance and ethical and regulatory considerations and stakeholder collaboration. If you see the domain knowledge, what is the domain knowledge? We are discussing about the agriculture models. So, for agriculture models, we need to have the agriculture domain knowledge, which is nothing but our crop science. So, how crops are developed and what are the advantages of crops, and next we should have a knowledge of soil science. Second, we should have the pest management knowledge, and we should know the weather patterns that are there in the particular location and the farming techniques that are used in both agriculture and horticulture. So, for domain from the knowledge, we need to identify the problem. So, problem identifying comes under the domain knowledge. Problem identifying is nothing but clearly defining the agriculture problem to aim to solve whether it is a yield prediction or pest detection or irrigation management or soil health monitoring system. So, these are the examples. First one is yield prediction, second one is pest detection, irrigation management and the soil health monitoring system. These are the problems that can be identified in the agriculture systems. So, for that to solve the problems that are identified, which is nothing but soil management or soil smart irrigation system, we need to collect the data. So how we collect the data? Collecting comprehensive and relevant data, including the historical crop yields, soil properties, weather data, satellite images and pest occurrences. These are the data that is relevant data required to do a project, and where we can find the data. So the data sources, identify the reliable data sources like KAGIL, government websites or government databases or research institutions, or from the IoT devices or the sensors or the satellites. From IoT sensors and drones and satellites we can collect the data. So the data can be very large, the data can be very small. So when the data have the volume and variety, ensuring the sufficient volume of data is required to capture or to solve the problem. Next, coming to the data processing, our next step is our data processing. We know that the data processing, as we studied, once the data is collected, the data is stored in Excel sheet or CSV file or JSON files. Once the data is stored in the databases, so the data can be processed. Here we have data cleaning methods. We handle the missing values, we handle the outliers and ensure that the data quality is improved. Next, data transformation, normalizing some data, scaling the data and encoding the data as required for doing machine learning algorithms. Next, doing the feature engineering. When we have lot of columns as inputs, we need to define or extract some particular columns so that can be used to predict the output well. So here we, in feature engineering, creating relevant features that can improve the model predictive power, such as combining weather data over specific period or calculating the soil moisture indices. So this is the data pre-processing. Next, coming to the infrastructure. So when we talk about infrastructure, two are very important. One is computational resources, second one is data storage and management. When we talk about computational resources, ensuring the access to the adequate computational resources, including the powerful CPUs or GPUs, storages and cloud services for processing easily and model training. So data storage and management, setting up the databases and the data management systems that are effectively store and retrieve the large data sets. Next, coming to the model training and validation. So we have the training data. Already we know that once the data is collected, the data is pre-processed, the data is featured engineered, so that we can divide the data into split the data into training data and testing data. When we have the data is divided into the training data, dividing the data into the training data and validation data and test data, and build the model and evaluate the model. So there is a need of cross validation. Using cross validation techniques, ensure the model robustness and also the overfitting, preventing the overfitting. And we calculate the performance metrics, which is nothing but accuracy, precision, recall. If it is a regression problem, we calculate the RMSE, MAE, MSC, etc. And we evaluate the models of regression with R square and with ROC and AOC curve. And next is coming to the, once the model accuracy is best, we try to integrate and deploy the model. So for integration and deployment, we try to see the scalability, ensuring the model can scale or handle the large data sets or real-time data streams. So next is coming to the integration, integrating the model into the existing agriculture systems and workflows such as farm management softwares or the IoT platforms. Next coming to the deployment, deploying the model into a production environment where it can be accessed and be used by the farmers, agronomists and also agriculture enterprises. Next, coming to the monitoring and maintenance, once the data is trained or ML model is trained, the model needs continuous monitoring, continuously monitoring the model performance in the real world to detect the drifts and degradations. Regular updating is very important, updating the model with the new data and retraining it periodically to maintain the accuracy of good, so that it reduces the false negatives and false positive and increases the accuracy of the model to predict correctly. Next is user feedback, collecting the feedback from the end users to improve the model and address any practical challenges are there. So once the integration and deployment is done, we need to monitor and maintain the deployed software or the model, AI model, which can predict correctly. Next, coming to the, once the model is monitored and maintained, it should also follow some ethical and regulatory considerations. So once the data is collected, we need to maintain data privacy. Once the data is collected from the end users, we need to maintain data privacy. So the data privacy is nothing but ensuring the data privacy and compliance with the relevant regulations such as GDPR or other data protection laws. Second one is ethical uses. Whatever the data is collected, we need to use ethically, considering the ethical implications of the model, such as ensuring it does not disadvantage the small farmers or lead the environmental harm. Okay, so ethically we have to use the data, and ethically we have to create the models or create the AI models which will not affect both the small farmers or the environmental conditions. Next, coming to the stakeholder collaboration. So once we have developed, we have integrated all the AI models and which have created a data privacy system, and also it is ethically corrected, we try to engage with the stakeholders, collaborating with the farmers. Once the AI model is developed, we collaborate with the farmers or the agriculture scientists, and we create a policy such that to ensure the model meets for practical needs and can be effectively implemented. Next is coming to the training and support, providing the training support to the end users. Once we have developed the soil management system or smart irrigation system or any agriculture robo, we need to make the stakeholder to use the system efficiently. Next, these are all the prerequisites that are there to design an practical ML AI based agriculture model. So always we build the model which can be a robust, and it can also it should also significantly enhance the agriculture productivity and sustainability. Next, coming to the next topic, advantages of AI in agriculture. So where we saw different steps to design the end-to-end model for agriculture. There are advantages and disadvantages. Where we have the advantages, one is improving the yield prediction. Always whenever we develop a model, we need to create a model which can accurately forecast the output. Second one is early interventions. It has to create a prediction model which can yield well. Second one is it should be a optimized resource management. When we are developing a smart irrigation system, it should it should reduce the water, and it has to create more and more efficient water usage systems or the targeted filterization. Next, coming to the AIE agriculture, the advantage is pest and disease detection. At the early stage itself, it has to detect the disease or integrate the pest management to the system. Precision agriculture, it solves the or improves the quality of the model. Site specific management system or variable rating technology. Next, climate resilience, it always creates weather adaptations or risk mitigation. Next, the advantage is cost reduction, lowering the input costs, efficient labor utilization, etc. Next is advantage is enhanced decision making, so data driven insights and scenario analysis. Coming to the sustainability, once we have developed the AI models for agriculture, it should have environmental protection and it also conserve some resources. Next, increase productivity. Once we have invested to design an AI project, always it has to increase the productivity of the system, optimized operations and continuous improvements. Next is market insights, demand forecasting and price optimization. Risk management, in the risk management we ensure that there will be a insurance models or the supply chain systems. Personalized farming, tailored personal recommendation systems. So once we develop a website for agriculture systems, we need to create a personalized recommendation system, or to educate the farmers, we try to develop systems, predictive systems. Global food security, increasing the food production and sustainable practices. These are all the advantages that we are that are improving the AI in agriculture. It is revolutionizing the farming and also the individual farmers, which give the broader role for food security and environmental conservation. Thank you.